Hello everyone, welcome again in Eng-Man YouTube channel. So today we are going to create nodal analysis from a multi-layer reservoir. So it will be a very interesting topic. So hopefully it will be useful for all of us. Okay, we will do the analysis within the Prosper software. This is the Prosper window. Okay, first we click this section. All right, maximize. You can follow me. Fluid description, fluid, oil and water. Method, black oil. Separator, single stage separator. No emulsion. And for the PVT warning, we can disable the warning. Water viscosity, we will use correlation. And viscosity model, Newtonian fluid. Flow type, tubing flow. Well type, producer. Okay. Artificial lift, none. We will not do any artificial lift analysis or design here in this video. Okay. You can also type any information that you think is important, like company, field, location, the well, and so on and so forth. And you can also type in your comments here. Okay. For the calculation type, we can follow the default, predict pressure and temperature, also model rough approximation, full system, default. We will do cased hole completion. For the send control, none, single branch, and no gas conning. Okay, done. Next, we will do the PVT analysis. So we can click this one, the second section. All right, so this is the PVT input data section. Okay, you can follow my data. Solution GOR, 800. Standard cubic feet per stock tank barrel. Oil gravity, 37 API degree. Gas gravity, 0.76. Water salinity, 23,000 ppm. Okay, and with no impurity. All right. The default correlation is GLASO for bubble point pressure, solution GOR, and oil formation volume factor. And the correlation, the default correlation for oil viscosity, usually Beal et al. And let's say we have laboratory data, so we need to do matching, so that from the matching that we obtain using our laboratory data, we can match with the correlation, and the match correlation can be used in our software for any analysis, nodal analysis, and so on and so forth. Okay, so to match the data, we click this one, match data. Okay, we need to input our data, our laboratory data, in this table. I prepared my data, so I can copy my data and paste on this table. All right. Okay, so you can follow my data for the PVT matching, for the pressure, gas oil ratio, oil formation volume factor, and oil viscosity. Okay, for the reservoir temperature and the bubble point, 210, 3500 PSIG. Okay, then we can click match. All right, so this is the matching window. We can click match all. All right, PVT matching calculations. The calculation has finished with the time elapsed here. Okay, so we already have the match data, the match correlation, and the match correlation we can apply within our analysis. Okay, we can check the matching quality, plot by temperature. Okay, we can check the matching quality for all the parameters here, for the bubble point, gas oil ratio, oil formation volume factor, and oil viscosity. Okay, first the calculated data, we click at temperature of 210. Let's say we want to check the oil viscosity. All right, this is the calculated data generated from the matched correlation. Okay, and match data, click this one, also oil viscosity. All right, this is our laboratory data. Okay, so as you can see here, it's quite matched. So we can accept the correlation, and later on we will use the correlation instead of the laboratory data. Okay, we can remove, let's say we can remove the calculated, and you can see we only have 5 points. This is our laboratory data. And for the correlation, we can click this one, oil viscosity. This is the results from the correlation after being matched. Okay, remove all, and we can also check the quality for the other parameters like formation volume factor. Quite good, right? Except in this section. But practically we can use this correlation. Okay. You can also check the other parameter, but let's say we already quite satisfied with the matching quality, so we can finish this section. Finish. Okay, you can also check the results, the table here. You can copy everything and paste on your Excel spreadsheet. And this is the plot. Okay. All right. This is the correlations, like for the bubble point, solution GOR, BO, we can select either Glasso, standing, Lassater, and so on and so forth. Also for the oil viscosity, we can select from these correlations. The best practice is always to check the background of each equation or correlation and compare them with the condition or the characteristics of your fluid. All right, so yeah, but usually, practically, we can select Glasso for PB, RS, and BO, and BL et al. For oil viscosity. Okay, but if you want to have a very detailed analysis, you can first read the background from each correlation, from textbook or from papers, and then check them with your fluid. Okay, we can complete this section. Done again. All right, also done. So we can see here the green light PVT is match. Okay, so far so good. So we are now prepared to do the reservoir section. Click this one, the third section. So this is the section for our reservoir model or for our inflow performance relationship model. We can select many models here like PI entry, Vogel, composite, Darcy, and so on and so forth. Today, we will do multi-layer reservoir. So we should select this one, multi-layer reservoir or multi-layer DP loss in wellbore. In our case today, we will select this one. Okay, multi-layer pressure drop loss in wellbore. All right, we can choose this one. The reservoir temperature is 210. All right. Now we need to input our data in this section for each layer. In my case, I've prepared my configuration and I can copy and paste here like this one. Very easy. Okay, let's check them one by one. So the top reservoir is at this value for the measured depth and for the true vertical depth. All right, the TVD is 9,000 feet and the MD is 9,275 feet measured depth. And we have several layers here. The first layer is perforated. The IPR model is Darcy. We can select other models also. Let's start with Darcy. And for the layer skin model, we can select by hand or using Caracas and Tarik equation. The second layer, no perforation, so we can select blank. Third layer, perforated, also Darcy and by hand. Fourth layer, blank, no perforation. And the fifth layer, also perforated, Darcy skin model by hand with their measured depths and true vertical depths. So please be careful here. You can input as per your actual reservoir characteristics, and each layer has their own characteristics or properties. In this case, the first perforated zone has layer pressure of 5,200 psig, and then the third layer and the fifth layer with their own reservoir pressure. Okay, and then we need to also input the layer flowing radius and layer roughness. So this will represent our wellbore condition. All right, so far so good. And then we can drag this to the right. We need to input PVT, model, and skin for each perforated zone. Okay, no problem here. It's quite easy. Let's open them one by one. PVT. Okay, for the first layer PVT, I will input these parameters. Okay, with the formation GOR, oil gravity, and then gas gravity and water cut. All right, so each layer has their own GOR, oil gravity, gas gravity, and including water cut also. All right, you can check the validation. The data on the screen are valid. Okay, good. And you can also click this one to change from the first layer, second layer, and so on and so forth. Okay, we go back to layer 1, done. Then layer model data. All right, we have the layer permeability, 71 millidarcies, right? With the drainage area, 400 acres, the edge shape factor. It represents a radial reservoir, 31.6, layer radius, layer wellbore radius. All right, this value, done. For the skin also, we can input 2 for the skin. For the first layer, done. Then the PVT for the third layer, all right. And then we can also move to layer 5, all right. And then the model for the layer 3, layer 4, no perforation, go to layer 5, all right. So we have completed all the layer model data, permeability, drainage area, shape factor, and also wellbore radius. Lastly, we will input the skin. The skin for layer 3, let's input 1, done. And for the fifth layer, the skin also 2, let's say. Okay, done. So this section, reservoir model, is turned green. So we have completed the data input. We can also check the validation. The IPR dataset is valid. All right, so far so good. Now we need to do the calculation. Calculate. All right, the calculation is completed. We can check the results, view results. Okay, you can copy everything. Okay, and then plot results. We can plot many variables, but of course, if you want to construct inflow performance relationship, for the x-axis variable should be rate, y-axis variable should be pressure, but we can also plot the temperature. Let's say we don't want to plot temperature because it's not that important in this case for now. So let's plot only pressure for the y-axis variable. Okay, done. All right. So we have completed the construction of our IPR for each layer and for the combined layer. You can see this one, this legend. The orange IPR is IPR from layer 1. All right. The smallest IPR. All right. You can check the characteristic, the properties for each layer to make sure why the IPR is represented like this one. Okay. And then for the second, the layer 3 IPR is this purple IPR. Okay. And then also for the fifth layer IPR is shown in this black IPR. The combination of all these layers will give this IPR. Okay. Named IPR results. Okay. So far, so good. All right, we can finish this section. Done. Done. All right, so we have completed our PVT data analysis, PVT data matching, and IPR construction. So far, so good. Okay. Lastly, we need to complete this section. All right, equipment data section. Click. We can edit all of these sections, but let's concentrate on deviation survey, downhole equipment, geothermal gradient, and average heat capacities. In this example, we will not do surface analysis, so we will not input in the surface equipment, and also we will not do input data for gauge details. Okay, after checking these sections, we can do edit. The first data input is deviation survey. I've prepared my data for the measured depth against the true vertical depth. Okay. So like this one, you can also see this depth is actually the depth of our top reservoir. All right. You can also check the plot. Okay, for the measured depth and true vertical depth. Measured depth versus cumulative displacement. Finish. Done. All right. So the second data input is downhole equipment input data. Okay, I've prepared my configuration. I can copy and then just paste it here for simplicity. Very easy. Okay, let's check them one by one. The first is Christmas tree. I need to correct this one. The measured depth is 0. All right, and then the tubing. The first tubing section, the end is 1,000 feet. Inside diameter, this one, with tubing inside roughness, this one. Rate multiplier, 1. And after that, we will have subsurface safety valve. Okay, you can just open this drop-down window and you can select tubing, SSSV, restriction, or casing. All right, we will have subsurface safety valve. All right, with tubing inside diameter of 3.72. Okay, no roughness, rate multiplier 1. And then we will continue our tubing section down to 9,000 feet, the same inside diameter, the same roughness. And then we will have our casing down to level of 9,275 feet for the measured depth. All right, the casing inside diameter is 6.4 with the default roughness. Rate multiplier also 1. So far so good. We can complete this section. And then we need to input the geothermal gradient. It's quite easy. with overall heat transfer coefficient of 8. Okay, you can follow this number. Formation measured depth with the temperature. You can also check the plot like this one. Okay, we need to check this number, finish. Okay, we can correct this one. It's wrong, should be wrong, right? Let's say we can plot, all right, or maybe 70. All right. Okay, so far so good. And then done. Lastly, for the average heat capacities, we can follow the default value for the CP oil, CP gas, and CP water. CP is heat capacity. Done. All right, we can check the summary for the downhole equipment. So first we can maximize, and you can check each section, and we can also draw downhole. All right. Beautiful. This is the Christmas tree starting from depth of 0, and then we will have our tubing, safety valve, tubing again, casing, and of course at this level we will have our perforation. Done, done, done. All right. So we have completed all the data input for the PVT, IPR, all right, and then also for the well itself, the downhole equipment, and so on and so forth. This is the picture of our well. Okay. And of course, we can now do the calculation. Go to calculation. We will do nodal analysis. So go to system, IPR plus VLP or vertical lift performance or tubing performance. All right. So our top knot pressure is 500. Top knot here is the wellhead pressure because our top section is Christmas tree, which indicates our wellhead or our top node. Okay, for the VLP, I've prepared my configuration. You can follow me. Surface equipment correlation, backsand drill, but we will not do any surface facility analysis here. Vertical lift correlation, petroleum experts, but you can also use other correlation. Solution node, of course, in our bottom hole for the nodal analysis location. Right method, I prefer automatic geometric. All right. And also for the left-hand intersection, stability flag, you can follow the default. Of course, we need to do the calculation. Press calculate, show calculating data. All right, the calculation is very quick. All right, fast calculation. Okay. You can copy the results and paste on your spreadsheet. But of course, we need to check the plot. Plot, system plot, plot all cases. In this case, we only have one case. X variable, liquid rate, because we want to plot our nodal analysis. Y-axis variable, VLP pressure, and IPR pressure. Done? All right. So this is our result. Okay. This is our IPR, the composite IPR, the combination from all the three perforated layers. All right. And then this is our VLP. Okay. You can also read the summary data. Fluid oil, PVT method black oil. All right, we will not do compositional analysis for now. And also flow type tubing, well type producer, artificial lift none, no sand control, inflow type single branch, no gas conning. All right. You can also minimize to maximize this window. All right. If you want to check the number, you can select plot setting, cursor data, show all, and then we can check the number by moving this cursor. Finish, maximize. This is the results. Liquid rate, oil rate, right? Water rate, gas rate, and drag down. All right, now you can check here. We can calculate the contribution from each layer, like this one. Layer 1 liquid rate will produce 4,351, the layer 1. This is the contribution from the first layer. And then for the second layer, all right, it's interesting. Not that interesting because second layer is not perforated. Go to third layer, right? Layer 3 liquid rate, this number, and lastly for the fifth rate. All right, you can also check again in the IPR section. Layer 5 has the highest or biggest IPR. So that's reasonable if layer 5 gives the highest liquid rate. All right. It's very, very interesting. Okay, we can complete our video here. So in this video, we have learned many, many things. We do the PVT matching, right? And then we input our IPR for multi-layer reservoir. We have the characteristics, the properties for each perforated layer. We have 3 perforated layers. We input the pressure, the PVT, the model, and also for the skin for each perforated layer. And then we generate the IPR for each layer. And then we also generate the combined IPR from 3 layers. Okay. You can check again, plot, done, right? It's very interesting. And then we have inputted the equipment data section, and then we have done the nodal analysis from a multi-layer reservoir. So that's all. I hope you enjoyed the video. I hope the video is useful. Thank you so much for watching. Please don't forget to like, subscribe, and share to your friends. And see you again in the next videos. Thank you.